Selection is what allows a program to branch out. Instead of following a single straight path, the program can evaluate a situation and choose the most appropriate direction to take, making our code much more flexible. These choices are grounded in Boolean logic. Essentially, the computer asks a question that can only be answered with true or false. Based on that answer, it decides which block of code to execute next. To make this clearer, let's look at some real-life conditionals that you already use every day. You are already a master of selection logic in your own life. Think about the weather. If it is raining, then you take an umbrella. If that condition is false and is sunny, you leave the umbrella at home. It's a simple binary choice. Similarly, when driving, if the light is red, you stop the car. By applying these same logical structures to our coding, we can build software that reacts to data and user input in real time. Before we dive into the actual code syntax, let's reflect on this for a moment. Building on what we just covered regarding decision-making logic, let's dive into our first actual coding tool, the basic if statement. This is a fundamental control structure. It acts as a gatekeeper, allowing your program to evaluate a condition and decide whether or not to run a specific piece of code. The execution rules are very precise. The computer evaluates the condition, and only if that condition is true will the subsequent code block run. If it's false, the program simply skips it and moves to the next part of the script. Look closely at this syntax. We start with the keyword if, followed by our condition, and we must end that line with a colon. In Python, that colon is mandatory. It signals that a new block of instructions is about to begin. One of the most important concepts in Python is indentation. Usually 4 spaces, this offset tells the computer exactly which lines of code belong to the if statement. Without correct indentation, your code won't behave the way you expect. Let's look at an example of an if statement in Python. The variable number is assigned the variable number is assigned the value 10. The condition number greater than 0 checks whether the number is greater than 0. Since 10 is greater than 0, the condition is true. So the indented line inside the if block is executed and displayed. After that, Python continues to the next statement outside the if block. Notice that the last print statement is not indented, so it runs regardless of whether the condition is true or false. The output shows that Python first prints that 10 is a positive number, and then prints the message indicating that the checking process has finished. This example demonstrates the key concept of an if statement. Python executes a block of code only when a specified condition evaluates to true. Building on the simple if statements we just practiced, let's explore what happens when we need a plan B. This is what we call binary logic implemented through the if-else statement. Think of the execution flow as a fork in the road. As shown here, it splits the logic into 2 mutually exclusive paths. If the condition is true, the program follows path A. If it is false, it automatically takes path B. A crucial syntax rule to remember is that the else keyword does not take its own condition. It simply catches everything that the if statement rejected. It's the safety net for your logic. This structure is perfect for binary choices, situations where there are only 2 possibilities. For instance, determining if a number is even or odd, or checking if a student's score results in a pass or a fail. Finally, look at this comparison table. While a basic if only acts when a condition is met, if-else provides a complete set of instructions for both possible outcomes, making your code more robust and predictable. Let's look at an example of an if-else statement in Python. First, the program asks the user to enter an integer. The input is then converted to an integer using the int function. Next, the condition number %2 equals 0 checks whether number is divisible by 2. If the condition is true, the number is even and the code inside the if block is executed. If the condition is false, the code inside the else block is executed, indicating that the number is odd. In this example, the user enters 8. Since 8 is divisible by 2, the condition evaluates to true and the program displays 8 is an even number. This example demonstrates the key concept of an if-else statement. Python chooses between two different code paths depending on whether a condition is true or false. In many cases, a simple yes or no isn't enough, and that is where the if-else ladder comes in. This structure is used when you have 3 or more exclusive outcomes. The keyword elif is short for else if it allows us to chain multiple conditions together in a sequence. A classic example is a traffic light. It isn't just red or green, we have that intermediate yellow light that requires its own specific instruction. Now, let's examine how this looks in Python code. Pay close attention to the syntax and how the conditions are ordered. Notice how we check each color in order. A critical rule here is that Python stops at the first true condition it finds. If the light is red, the stop function runs and the program skips checking the yellow or green conditions entirely. This makes our code very efficient. Finally, the else at the bottom serves as our catch-all. If for some reason the light isn't red or yellow, the code defaults to the go action. It's a safety net for any case we didn't specifically define. Let's look at an example of an if-else statement in Python. This structure allows a program to check multiple conditions and execute the appropriate block of code. In this example, the variable number is assigned the value -5. Python first checks whether the number is greater than 0 using the condition number greater than 0. Since 5 is not greater than 0, this condition is false. Python checks the else if condition number is less than 0. Since -5 is less than 0, this condition is true. So Python executes the corresponding code and displays the number is negative. Building on the complex branching we just covered, we can make our decision making even more precise using logical operators. This allows us to combine multiple conditions into a single powerful Boolean expression. First, let's look at and think of this as a strict requirement. For an AND expression to be true, every single condition within it must be true. If even one part is false, the whole thing fails. Next, we have the OR operator, which is more flexible. It only requires at least one condition to be true. If you have 5 conditions and only one is met, the OR operator still evaluates to true. The NOT operator is the simplest but very useful. It's a logic flipper. It inverts the value, turning true into false and false into true. It's great for checking when something is not happening. To see this in action, look at this range checking example. To determine if a number x is between 1 and 100, we need to verify 2 things. Is it greater than or equal to 1? And is it less than or equal to 100? Both must be true for the number to be in range. Let's look at an example of using the logical operator in an if statement. In this example, the variable num is assigned the value 50. The condition checks 2 requirements at the same time. Num more than equal to 1 checks whether the number is greater than or equal to 1. Num less equal to 100 checks whether the number is less than or equal to 100. The AND operator means that both conditions must be true for the code inside the if block to execute. Since 50 is between 1 and 100, both conditions are true, so Python displays the number is between 1 and 100. This example demonstrates the key concept of the AND operator. Multiple conditions can be combined and the result is true only when all conditions are satisfied. Let's look at an example of using the logical operator or in an if statement. In this example, the variable user roles is assigned the value admin. The condition checks whether the user's role is either admin or superuser. The OR operator means that at least one condition must be true for the code inside the if block to execute. Since user roles is admin, the first condition is true. Therefore, Python executes the print statement and displays You have elevated permissions. This example demonstrates the key concept of the OR operator. When multiple conditions are combined, the result is true if any one of the conditions is satisfied. To finish our session, let's look at some best practices and summarize everything we've learned about selection structures today. First, always choose the simplest valid structure for your problem. We use a single if for one logical path and if-else structure when we have two distinct choices, and the if-else ladder when we need to handle multiple specific conditions.